We're now going to look at critical path.
The critical path method was developed by DuPont in 1950. Its intention is to determine the amount of flexibility or float you have within task and within your whole project. It determines the minimum duration of a project. It's also used to prioritize activities, so you know what tasks are critical, and then if you need to, you can put more resources towards that particular task to bring it back on schedule. Now, let us look a little bit more closely of how we go about determining what a critical path is. So what you're going to see here is you're going to see this little diagram here that has a description. That's the name of the actual task. And within that, we have 6 squares. And the squares represent particular values. In order for us to do a critical path, we really need to do what's called a forward pass and a backwards pass. And I'll explain that as we go through. But let's have a look at some of the things. DUR stands for duration. It's really at this particular point in time. This duration comes from our work breakdown structure, and it's actually the only thing we actually know at this point in time. ES means the earliest this task can actually start. EF stands for the earliest this task can finish. Then we have LF, which is the latest this task can finish. And then we have LS, which is the latest this task can start. And then ultimately we have float. Now, float is the project management term for flexibility, the amount of time or the flex time that you have in this task before it absolutely has to be completed. Now, what I'm going to do now is walk you through how we actually do a critical path. The first process that we go through is what's called a forward pass. And a forward pass starts at the left and goes to the right. And basically what it does, it wants to compute the earliest a task can be finished. So what we do, you take the earliest a task can start plus the duration and give us the earliest it can finish. I'm going to walk through it now. Look at task 1.1. I'm just going to put 0. I know mathematically that's not correct, but 0 and 5 will give you 5, and that makes for easy math as we go through. So on task 1.1, the earliest we can finish is 5, whether it's 5 days, 5 minutes, 5 years, doesn't matter. As long as your durations that you have, your time frames are consistent, it'll work. Now let's go look at the next one, 1.2 at the very top there. Since 1.2 relies on 1.1 to be completed before it can start, then the earliest it can start is 5. We take 5 plus 2, and what gives the earliest it can finish is 7. Let's look at another task. Let's take 1.3. Again, 1.3 relies on 1.1 to be completed. So the earliest 1.3 can start is 5. 5 plus 3 gives us 8. Now you're sort of getting the hang of this, so I won't repeat too many things, just so you can get the hang of it. You can see where the numbers are coming from. Let's look at task 1.5. 5 plus 3 is 8. Let's continue on. 1.4 now gives us 8. 1.6 now gives us 16. 1.7 now gives us 11. Earliest it can finish. 1.8 gives us 16 and 6. The earliest it can finish is 22. Now for the very last task, 1.9, since all the other tasks to the left of it have to be completed, then the earliest it can start is when all the other tasks are actually completed. So in this case, it can't start until 22. The 22 and 5 is 27. So now this is actually telling us that the quickest we could actually do whatever this group of tasks are is 27. Again, 27 minutes, 27 hours, 27 months, whatever duration that you use, whatever symbol or degree of time that you use for that, that's what it's really telling us. So that completes our forward pass. We'll go on and do a backward pass. Now we're going to do what's called a backward pass. We're going to start at task 1.9 and we're going to end up at task 1.1. And how we calculate that is we want to compute the latest a particular task can start, and we do that by taking the latest it can finish minus duration. Let's have a look at it. Starting with 1.9. 1.9, the latest it can finish is the same as the earliest it can finish is 27. So 27 minus 5 is going to give us 22. Take another task, which is 1.8, is 22 minus 6. Now I'll just run through these particular tasks going backwards, and you can see where we get the numbers from and how it's calculated. Pretty straightforward, pretty easy to do, simple math. I'm on 1.2 right now. And ultimately, we get to the end of it, going backwards to task 1.1. and we take 5 away from 5 equals 0. So there we have our backward pass. Now we're going to do one more thing to determine what our float is. So now we're ready to do the last step in calculating the critical path. We've done our backward pass, our forward pass, and now we're ready to do and determine what the float is, or the flexibility is for each one of the tasks. We're simply doing that by taking the latest task and finish minus the earliest task and finish, and that will give us our float. So let's start. Task 1.1. 5 minus 5 is 0. Task 1.2. 18 minus 7 is 11. Pass to task 1.3. 8 minus 8 is 0. I'll go through the rest. You can see how we're doing. Task 1.7. 22 minus 11 is 11. Task 1.8. 22 minus 22 is 0. To the last task, 1.9. 27 minus 27 is 0. So now we've gone through and we've determined all the float or the flexibility each one of the tasks. What we really need to do is look at what the critical path is. Now I've done this quite obviously in the red. Is a critical path on any schedule is all the tasks that have the least amount of time for the flexibility or for the float. Now, the question is, can you have multiple critical paths in a project? The answer is absolutely you can. But that's the way you determine. So those are the critical elements. Now, the whole idea of coming up with a critical path is to say, as you go through and you start to do the work, you can see where you can allocate resources if you're getting a little bit behind or you have limited resources. So, for example, in this diagram, when we look at task 1.2, 1.5, and 1.3, once 1.1 is completed, we have options now. If we only have limited resources that can do all the three next tasks there, 1.2 and 1.5 and 1.3, we most likely would put that limited resources on 1.3 because it is crucial or more critical than the other ones. It has less flex time. Again, it has 0 flex time. That means it has to be done right away, whereas the other ones will have 14 and 11. That gives us more time to do that. So you can see how by determining your critical path, you can allocate resources to make sure your critical items are done or critical tasks are done before some of the other ones that have more flex time. As a project manager, it gives you a lot of flexibility or a lot of leeway where you can allocate limited resources or you can readjust your project to make sure that you are successful.
This is the end of the video on critical path. Up next is the video on how to create a project.